Okay, so uh, in several cases, you're going to have to find the height of the triangle, which is usually a dashed line. Okay, so I'm going to show you, first of all, that sine law works to find out, yeah, cosine law won't really be used a whole lot. And I can tell you this already, sine law is going to be the most used law of them all. So we're going to do cosine law and sine law, but sine law is the most popular one. Okay, it's just because it is able to solve more cases. So keep that in mind. So calculating, the height is always measured. The height is measured perpendicular to the base. So that means that there's a 90 here if this is the base of the triangle. But keep in mind that this triangle could be rotated every which way, and this would still be the height, right? If I had it drawn like this, we would still consider that, and this, like in some scenario, we're going to call that depth, right? Like when it's like that, we usually, it's like the depth of the like the lake or whatever. It's just the same idea. You're still finding the line that's perpendicular to the one of the sides and goes to the highest or lowest point for that matter. So we have, I'm gonna highlight this like so, because it's not really a side length, it's basically an imaginary line inside. That's why it's dashed, right? So when there are dashed lines, just like remember inscribed polygons, don't focus on them first. Focus on the big shape first and foremost, okay? So we're gonna split this triangle into two parts. And I'm gonna work with this one first. So if we cut out this triangle, which is triangle number 1, this is our height. The 4.52 over here, we can transfer that. Okay. The 8.2 we cannot transfer, correct? And we can also not assume that we can split it in half. You can't assume that because, by the way, this is not an isosceles, right? See how there are different angles? If these angles had been exactly the same, then this would be a symmetrical shape. So then technically, yes, you can cut this in half, but we can't go there. So 59.8 comes over here. That we can transfer, and that's about it. So I'm gonna just do this as well. And there's a purpose for this. So I'm actually gonna highlight this diagonal, whatever color, the color of your choosing. I want to highlight that. And so in this case, mark my words, these diagonals are given, but they may not have been given at first. So you may have to solve for them before you even start doing anything else. So in this case, it's already provided, but at this point, you have a 90 here. So if there's a 90 there, it's safe to assume it's a 90 because it's a straight angle here. That's why I've made that a 90. And you have your pair there. That's pair. So that's your sine law. This means that you're going to have to use the sine law to solve this one. So we go sine of 90 degrees over 4.52 feet is equal to sine of 59.8 degrees over the height. And there you have it. So height will be found by multiplying these two, 4.52 times sine of 59.8 over sine of 90. Try out what sine of 90 is, so it's a good one to remember. Sine of 90 degrees is 1. So if you remember that, you can omit that step. You don't really have to divide in that case, right? So 4.52 times sine of 59.8 divided by sine of 90, nothing is going to change. still 3.91, right? So height is 3.91 feet. There's your height. There's the height of the triangle. Let's cut out the other side. Do that here. It's a bit longer, right? You have the 90. This is just to show that it doesn't matter which one you use, you will get the same answer. So we will highlight this one pink, just like I did above. And now I'm going to pick a different color for that diagonal there. And I'm going to match it on the larger triangle. Like that. And so we are in the same boat here. Sine of 90 over the side that's across from it is 7.1 feet. And on the other side, you have sine of 33.4 over h. Always remember, I cannot cover every single scenario. But you do know, right, that if you have a 90 here, you have two angles. You can easily find that third angle up here if you needed to, right? That shouldn't be a problem. Let's move that. So let's solve this. H would be same thing, 7.1 times sine of 33.4 divided by sine of 90. Here it is. Make sure you close the bracket, right? Because sine automatically, so if you don't close the bracket and you just go divide it by, it's gonna take that division perhaps first before applying sine. You only want sine to be applied to the angle. To accommodate for that, I just do that first and then I divide usually. And dividing by sine of 90 doesn't change anything. So there's your 3.91 still, which we expected, right? Regardless of which side you took, you got that. Okay. Now I want to give you a shortcut to avoid having to do all of this work. And here it is. To find the height, all you have to do is side length times sine of adjacent angle. And I will make a I will give you some scenarios right underneath this, as you can tell. That's important. That's a shortcut to finding. So for example, in this case here, if you look at this triangle, I'm going to just highlight that in green like that. And maybe orange for the angle. So adjacent means touching, right? I don't know if you remember that. Adjacent means it's touching it. So if this is the slant height you're thinking of, then it's that angle right there that you want to use. So this particular triangle, if you wanted to use the height, all you have to do is PQ, right? PQ times sine of this angle, in this case would be called P, right? So PQ times sine of angle P. And I'm going to leave it at that. I used to have this side as well, but I think I'm just going to leave it at that for now. Next, if you're focusing on this triangle here and you wanted the depth of this triangle, also height, let's say we come from this side. If you know this slant, then you want to use this angle here to figure out the height. So in this case, height would be EF times sine of E. That's the shortcut. I hope you like it. And it's going to come in handy in chapter 4 when we do that special case. This is going to come in handy as well. So not only will we use it here, it comes in the back. So what if the height is outside the triangle? What's up with that? Okay. It's the same thing. You can pick either one. For all of these triangles, you could have picked this slant, but then you would have had to use this angle here, because this is the one touching it, right? If you wanted to do this triangle, if you knew this slant and you wanted to use this slant instead, you would have had to use this angle, right? So just keep that in mind. So for this one, you can pick this side. Let's say you know that slanted side. Let's go with it. And you need to use this angle here. Right? That angle there is the one that's touching that side. So to find H, we would go QP times sine of angle P. Let's try it. Let's put it to the test right now. Because I don't know. Sometimes I trust Mr. Dirksen. Sometimes I'm like, I don't know. You're making stuff up here. This is not going to be in any textbook, by the way. It's just, I just find it so much faster. I like patterns. So let's try it out with this triangle up here that we just did, without writing anything down. You're just going to be like, hey, I wonder what the height of this thing is. Oh, I know this slant height here, 4.52 times sine of the angle that's touching it, 3.91, which is what I determined, right? Oh, what if I only know this slant and that angle? Oh, no problem, 7.1 times sine of 33.4, right? Slanted side times the angle that's touching it, 3.91. So that's the quick way of doing that. However, you're ready for this? You may not know these sides right from the get-go. I kind of fast forwarded to that point and just focused in on finding the height. So you may have to ignore that first and try to solve for one of these slanted sides before you can go ahead and find the height. Okay, so you need to keep that in mind. So, what am I going to do here? I think I'm going to go back in time a little bit. And I'm going to ask you to try 11. So go to page 11 here. Go to page 11. I want you to try that one. Read the question. It's starting to be more wordy. Okay, you got to actually read the question, see what is it asking me to find. So I want you to try page 11, and then I also want you to try page 12. Go with me to page 12 here. What is it asking you for? Determine the area of the triangle. To 2 decimals, please. Even if it says 1 decimal, I just forgot to edit that out. You remember the area of a triangle formula? Base times height. Oh, there's the height. I'm going to need to find the height, I'm guessing, right? Divided by 2. That's the area of a triangle. So that's why the height comes in there, right? So pages 11 and 12, give it a try. And then I'll come back and do it with you together. But I want you to, there's lots of space, so even if you get it wrong, leave your mistake and we'll just do it right underneath it. Okay? So go to town. Can happen. Okay. So maybe if you, even if you did it and you think you nailed it, maybe pay attention to some of the things that I'm highlighting, right? Some of the things that I'm mentioning that will help you in the future. So in this case, if you read it, it says determine the depth of the gorge, right? So let's call this D. I know some of you call it H, don't erase it, it's okay, right? But it's our depth, okay? But notice, I will make a note, none of the slants are given, right? That makes this actually, as it is, impossible. If you were to cut this, you cannot use the 21 with you. You cannot bring it with you. So literally you have no side. So you need to pay close attention. You need to figure out this one or that one. It's up to you. But you need a slant. Okay? Focus on large triangle. Ignore dashed, right? These are like notes for you later on when you review it. It's like, what did we do here again, right? Ignore dashed lines at first. That's basically my message to you, right? So we're just gonna say, let's just take this triangle, and we know this is 60, this is 75. Let's ignore the dashed line. We know that this is 21 meters here. No pair, right? This is the hidden pair scenario of sine law. Let's try to find this one. Okay, this one here. What are we going to call this? We're going to call this A, B, C. So angle C is 180 minus 60 minus 75. And you might have to help me here a little bit. This is 60 and that's 135. So this is 45. Thank you. It's Monday morning, remember? So that would be step number one. Like I'm going to find this 45, which now allows me to have the full angle there. Okay. So let's solve for one of these. Which one do you want to solve for? I don't know what I did on my key, to be honest. I don't have it in front of me. I'm going to go with this one, but it doesn't matter. Okay, it doesn't matter. So I'm going to go sine of 45 over 21 meters. And then I have to pick, I'm going to pick sine of 60 to solve for angle x. Side x, sorry, not angle, side x. So x is 21 times sine of 60 divided by sine of 45. Right? I need a music in the background there. 72. What are we at? Meters, right? So also important, but I'm not done yet. So now, which one are you going to take? Like, if we go back up to the original, 2572 is this one here. So I'm going to take this triangle, right? I'm going to cut it here and take this side of the big triangle. So I'm going to go like this, 2572. I cannot use the 21, but I can use the 75, which will allow me to solve for D. Okay. So sine of 90 over 2572 is equal to sine of 75 over D. And that would be 2572 times sine of 75 divided by sine of 90, which is irrelevant, but we don't want to forget about that step. Oh, I'm doing it the long way, right? I showed you the shortcut. Sorry about that. It doesn't matter. You get the same idea. Why would you do it the long way if you showed us the shortcut? 24.84 meters. That's a weird looking too, I know, but that's Monday. For 12, the key is posted for that one, right? So I think I'm just gonna leave it at that. What you need to remember is when you don't know which one your base is, whichever side you use to multiply it by the angle, right, that would be your slant. So the base is the other one that connects with that angle you're using. So the key is showing you how to do that. And so, hold on, don't pack yet. So this one, key is posted. Key posted, what is it, November 3rd? Okay, so if you want to go back and check, that's where that key is. So I'm going to ask you to go 13, okay, here it is, ready? 13, 14, so that's the homework. Let's put it on page 13. 13 to 14, and then I want a couple that involve a height. So I'm going to go past that, and I'm going to say 19 to 20. Okay. There's basically just 4 questions here. Okay? It seems like a lot of pages, but it's not like your textbook and IPR. That would be insane amount of work, right? Because it'd be like A, B, C, D, E, F, G, everything. It's a lot of work, right? But that's just 4 questions. Maybe if you do one of each, one of these two, one of those two, then at least you're in the game. Okay. I would like you to do all of them, but you decide. You prioritize as you need. You're getting close to that age where we can't tell you what to do anymore.